these things, melanin, hemoglobin, DHA, water. Light is the source of external energy to allow for that conduction to happen. But the parameters need to be very specific.
Tristan Scott is an electrical engineer and holistic health practitioner who has done extensive research into the biological effects of non-native EMF, or electromagnetic fields, on the human body. As the author of the book Bitcoin and Beef, he is also a strong advocate for decentralizing agricultural and monetary systems through regenerative farming and digital sound money. We recorded a massively wide-ranging discussion, which I've actually had to divide into two parts. In part one, we cover humans as electromagnetic organisms, the health consequences of removing ourselves from the Earth's natural electromagnetic field, why the scientific knowledge on this topic is covered up, the healing power of nature, and how to mitigate non-native EMFs in your house and daily life. Okay, Tristan, thanks for joining me on the podcast.
Hey, Max, how's it going?
Good, man. Well, I've been looking forward to talking to you. You post very, very interesting pictures on social media of you camping out in the wild with a bison skin, drinking stream water. But you're also an electrical engineer, and you're doing work with regenerative bison farming and promoting the health effects of non-native EMF. So a really bunch of interesting stuff that you're doing. So thanks for coming on. And maybe we could just start the podcast with how an electrical engineer becomes so interested in human health.
Yeah. Thanks for that. It's fun to be kind of, I guess, well-rounded in that sense. I'm just really passionate about a lot of things. And now it's really cool because you realize all these things are connected, and you look at this through a decentralized lens, and you can really never go back. And yeah, you mentioned that, and I'm yearning today because I'm going back out to the mountains tonight to hopefully be more successful in my hunting trip this weekend. But it's really what I'm all about. And once you go back, once you get out in nature, I feel like you're just addicted. But for me, I kind of grew up. My mom is from Austria. We grew up hiking. We grew up camping. But then being raised in the U.S., you kind of, once you're a teenager, just lose touch with a lot of these things, going to university. I played soccer at university, was electrical engineering students. You're just so busy. You're caught up in, I guess, the grind, really, and did plenty of the, vices that come with just being a university student. And one day after my playing career was over, I just, I lost consciousness and hit my head and ended up suffering a concussion. And I didn't know that I had a concussion. So the acute recovery phase, which is extremely important for concussion recovery, probably, did everything wrong. And I had, concussions in the past from playing soccer, playing football, I guess, for your audience. And yeah, it led to a severe health issue for me. So I had post-concussive syndrome for many months, ended up being, 12, 15 months of daily symptoms, headache every day, extreme fatigue, irritability, sensitivity to noise, light, sound. And I had no answers. 3-4 months in, I went to a neurologist, and I was so excited when he said the words. He's like, I think you have a concussion, like based on your symptoms, your EEG's clean, you have a concussion. Because at that point, I didn't know what was going on, really. I had a good idea. And then I was so relieved. And then the next moment I asked, what can I do to get better? And he said, just take it easy and try and slowly get back into your normal routine. And then in that moment, I just, full on depression, because it's really hard when you go from just being a high functioning person like I was, engineering student. Electrical engineering is not an easy degree. I was in the library for 30, 40 hours a week, playing soccer for 30, 40 hours a week, just grinding, but high functioning person. And then that all goes to zip, that all goes to barely being able to get through coursework, sleeping 12, 13 hours a night. And then this guy is telling me, just take it easy and, get back into your routine. And I just couldn't believe that that was the answer from what I now know is, the centralized system of healthcare. So it was a rough few months after that. And then thankfully that summer, so about 5, 6 months after the injury, still having symptoms every day, I had an internship in Oregon. And I was really getting connected with nature. My roommate was taking me camping, hiking, and these are things that I hadn't done a lot since I was maybe like 12 or younger. And it really rekindled my passion with the outdoors, and I felt better. I don't know if it was the lack of stimulation, the lack of, EMFs, what have you, just not being on a screen all day, artificial light. But at that time, I realized that when I was in nature, I felt better. I could actually go hiking and not have these issues. Because at this point, I couldn't even go for a jog, really. And that kind of started my recovery, my self-healing path. I decided I had enough. I was, I'm pretty stubborn, can't take, these answers from doctors and tell me that this is the new normal. That was unacceptable for me. So I started meditating. That helped clear my mind. And then I just started reading, started researching books, self healing, YouTube videos, podcasts, all about, health, optimal health, recovery, Ben Greenfield, all these guys. And I realized there's whole amount of information available to you for free, really. And I started to implement things in my diet, my lifestyle habits, and they started working. Taking some specific supplements for brain healing, and I started to feel better. And from there, I was hooked, really. And that was kind of late 2018, early 2019, started to feel better. And then I realized, this is something that I'm passionate about. And it ties into, what I was getting more into was back into the outdoors. So from there, the past 4 or 5 years, I've just been fine tuning my lifestyle habits in terms of health optimization. And for a while, is big on diet. You go down the diet rabbit hole, you learn about the food system. Then I started getting into regenerative agriculture. I moved out west. My sister lived in Wyoming. We started buying like quarter, half beefs. So I got really passionate about regenerative agriculture, restoring the land by emulating nature, biodiversity, and I ended up writing a book that was half about that story, and became known as kind of a guy, a meat and regenerative ag guy, which is funny. And still a lot of my Twitter followers probably follow me because of that. But in the past year, and even back then, like, I started just being a biohacker, quote unquote, which I hate that word. And I actually was going to call my book Bitcoin and Biohacking, but then I was like, I hate that so much. So I changed it to Bitcoin and Beef. And yeah, I was wearing blue light blocking glasses like in 2019, even though they were crappy ones. I was turning my phone on airplane mode. Like, I was aware the importance of circadian rhythm, EMFs, but I never took like a really deep dive because I kind of focused on writing my book instead. But then after that wrapped up with the second edition last year, I decided to do exactly that. And it's just been profound. And I never thought my electrical engineering background would be so pertinent to health optimization. But as you know, as your listeners know, we're electromagnetic beings. Our biology is really designed to be compatible with the electromagnetic environment that we're in. And having that fundamental background in electrical engineering has allowed me to, grasp these concepts maybe easier than someone else, but also kind of go back and relearn concepts, apply critical thinking, because there's not a lot of research in spaces like grounding and EMFs. There's a whole slew of this. So I'm using my background to understand the mechanism and then tie it to the biological piece, which to me is just really exciting. And as I told you pre-show, I really was never excited about electrical engineering in university. It was just too much burden, really, just trying to grind out the degree. But now, or in my job, your day job, working for a big corporate company. But now, for the first time, I'm actually really passionate about electrical engineering and EMFs and the circadian and quantum biology components. And it's really exciting to be on the frontier of this education and knowledge, I would say.
Yeah, epic, mate. And it's incredible how there are threads that are running through all these different areas of interest that you've mentioned. And like you said at the beginning of the podcast, I think decentralization is the key concept here. And decentralization in agriculture, and that's something that I promote on my podcast. Decentralization in health and health information, which is what this podcast and your podcast is about. And I think this is going to be the way forward. So it's really exciting to talk to someone who is so deep down the various rabbit holes as you are. I like this idea of nature as a healing entity, or the therapeutic protocol is Mother Nature. And Dr. Jack Kruse kind of has written that in the past famously. Here's a prescription, sunlight. And I really feel like I could do the same. It's just my prescription is sunlight. And when you told me your story of your healing, you finally got better when you got back out in nature. It reminds me of a patient story of someone with quite decent going depression, and it took an extended camping trip where they were grounded, seeing the sunrise every morning, eating wild caught fish, which we know would be rich in DHA, which is essential polyunsaturated omega-3 fatty acid. Having fires at night, going to bed with the sun, and the depression lifted. And if you it's so simple to say, okay, it's just nature. But if we break it down from a scientific point of view, they were doing everything right to promote optimal mitochondrial function, optimal circadian rhythms. So I love it how it was your experience, your personal lived experience that then helped you kind of go further down this path. The next topic, where I want to take this, and this can be quite a winding interview, but this idea of humans as a electric being is a fascinating one, and again, one that centralized medicine doesn't recognize, or it's not part of our treatment protocol. So, to talk to us about how and why we are an electric being.
Yeah, no, and totally. Just going back to quickly your point on nature, something that's funny that I thought about is, you go out camping for a while, and people are always like, oh, this is nice, but time to get back to the real world. That's incorrect. I mean, nature is the real world, and that's what our biology has been designed to live in. And it's now only recently, right, the past 150 years, and yeah, farming and other things existed like 10,000 years ago. But and depending on the community heritage, but this is where we were designed to live. This is how we were designed to function. And that ties in to being electromagnetic beings. And there's examples of this just across the board, right? Brain waves right off the bat. We know like alpha brain waves are 7 to 10 hertz, and the other brain waves are either slightly above or slightly higher than that in terms of frequency. We have, an electrical system regulating our heart rhythms. We have, the mitochondria in general. Mitochondrial membrane potential is the voltage. A proton current is driving this, and we have a nanomotor spinning out ATP. We have and generating magnetic field doing so, and just the list goes on and on and on. We have the ability to ground, and I know you want to get into that a little bit, and that's the absorption of free electrons. But this really starts with, for me, it started kind of, I knew about grounding, I knew about EMFs, but diving deeper, you realize there's so much more. And then you start to realize that this is really the foundation of health, because the biochemistry doesn't do enough to explain what's going on, and it's not fast enough. It's not quick enough in communication. So there's a big gap there. And it's really a shame, because I would say that's what our education is based on, is really biochemistry. And for me, it's been fantastic, because guess what? I have no background in biology or chemistry except from high school. And there's very, very, minimal. So I come in here like completely, I don't need to unlearn anything, which is maybe even better. And then I have this background in electrical engineering. I'm like, yeah, this makes sense. But really for me, yeah, reading like The Body Electric, Invisible Rainbow, books like this kind of cemented it. And it's crazy to think about Robert O. Becker's work, in the 70s. And you could go back to, St. Georgie talking about proteins as semiconductors before then. But foundationally, we're electromagnetic beings, and we rely heavily on biological semiconduction to function properly, as well as a water protein matrix that's driving communications faster than any biochemistry could ever, as well, through kind of a semiconductive process. So there's just a whole slew of examples, but at the end of the day, I think you could go through every major system in our body and realize that we are being driven by electromagnetic forces. And you can look just right to the mitochondria because they're in every system, every cell in our body. And the most mitochondrial rich areas tend to be the ones that are most affected by non-native EMFs. And that's not by mistake or coincidence. That's because they're very electromagnetic rich, I guess, pieces of the cell that are using these forces to drive our biology. So that's kind of how I looked at it, and we can dive down some rabbit holes there if you want. But it's a very eye-opening realization to make when you realize just how important electromagnetism is for our biology.
Yeah, mate. And I've talked to a couple of engineers in on this podcast so far, and you made the point that you didn't have to unlearn anything. And I think that part of getting to where a lot of people have in my profession is that we get colored. We get colored and influenced by the prevailing narratives, you could say dogmas of the day, and they become almost blinkers or kind of guardrails that prevent us from exploring concepts outside the orthodoxy. But the engineering approaching these topics like health from an engineering mindset is an ability to purely apply first principles thinking, be completely unshackled from any kind of orthodoxy, any kind of paradigm that might prevent us from getting to the truth. And we get told in medical school, you're going to get about half of what you're going to learn by the time by the time you graduate by the time you've finished your work is going to be incorrect, but we just don't know which half. So I really appreciate your perspective as an engineer, because I think it really allows us to get a really fresh set of eyes on the projects. And it actually also reminds me of, I've got a couple of friends in finance, and these hedge funds, they don't employ people with economics degrees or at all. They actually look for physics PhDs, because they're looking for the most objective thinkers who are highly logical,
Mm-hmm.
highly rational. And I think if medicine and health had more engineers like you, like Robert, like David Feldman, who's looking at lipids at the moment, like Scott Zimmerman, who I interviewed recently on near infrared light, I think we'd be getting much further down the rabbit hole. I made a little. I'll just correct what I said a bit earlier about centralized medicine not recognizing the electromagnetism of the body. That is incorrect to a degree, because, as you mentioned, the profession of neurology uses measurement
Mm-hmm.
of a brain electrical activity, and as you mentioned, it's called an electroencephalogram, or which is measuring the wavelengths of the brain, and we use that to diagnose things like epilepsy and the cardiology profession. So when
Mm-hmm.
a patient is coming in with chest pain into the emergency department, we're going to do an ECG, or you guys call it an EKG, and that's looking at electrical conduction through the heart. So there is specific kind of instances where centralized medicine, mainstream medicine, recognizes the electromagnetic nature of the human body, but I feel like it's so selective, and so often it's domain specific. Like, we're appreciated in one domain and then completely ignore
Mm-hmm.
the rest of the implications. So tell us a bit more about Robert O. Becker's work, because that's a prelude to what we're going to talk about next. So what did Robert O. Becker study, and what did he find?
Yeah, and that's a great point on the EKG and the EEG. It's so silent. It's like, oh, we just stop there. It's like how people, I think of people when they start learning about how corrupt the food system is, or pharmaceutical industry, and then they just stop there. And I'm like, no, folks, there's so much more here. Let's keep going. Like, let's keep discussing what's going on. So, but yeah, Robert O. Becker, I mean, foundational, I think like I said, the most important stuff that he found from the biological aspect is the fact that we have semiconductors driving our biology. We have electric electrical components in our biology, and we're using that conductivity to drive communication and drive healing and drive just function across the board. And later, he's a big proponent on EMFs. But starting with the semiconduction, he basically proved that via the discovery of bone being comprised of collagen, which is an N-type semiconductor, or negative, and apatite is a P-type semiconductor. And they are also doped with copper pegs, which is important because in semiconduction in the industry, like oftentimes impurities are added to improve conductivity or influence semiconduction performance. But basically, those P and N type semiconductors form a PN junction, which is otherwise known as a diode. And in engineering, diodes are used as an electrical component to allow current to flow in one direction when you bias a voltage on it, forward direction. And yeah, you basically get a diode from bone just by design. And you have the holes on the P type side, the electrons on the N type, and you have a depletion region in between. And that allows semiconduction to occur. And that's basically what Becker found. And then he was doing all these cool experiments by shining light on the bone, realizing that it's photoelectric, realizing that it's an LED also, because which is just a light emitting diode. So he talked about the fact that it's a diode. So when an outside source of light was shown on the bone, that stimulated current flow, semiconduction, and then it emitted its own light, its own infrared light. So you can think of bone as an LED, and it just goes on from there. He surmised that those copper pegs, when they become degraded, that is actually a leading indicator or sign of osteoporosis. And he thought that that was due to electromagnetic forces changing in the environment or exposure to maybe non-native EMFs. And how did he back that up? He looked at what was a really popular, topic at the time was space travel and astronauts. Soviet and American astronauts at the time were dealing with really, really high rates of osteoporosis. So his hypothesis was that the non-native EMFs or the leaving of the natural EMFs that we should be exposed to was driving this degradation of those copper pegs and degrading the ability of bone to be a functioning semiconductor. He found that collagen was piezoelectric, which that word's thrown around a lot on Jack's podcast. All that means is that you can translate mechanical energy into electrical energy. So that's an important concept. And then other things, right? Like he was studying frogs and salamanders and injury currents, kind of how that signal is being generated. And from my takeaway, what was cool about that is, yes, he showed that there's electrical communication happening via injury currents. But for me, it was how minuscule the intensity or the level of current that was generated for that signal. And it was only when he scaled, like he did a crazy experiment where he was inducing this current for like 200 days and lowering the current every day to see if that would generate the injury response for healing. And it wasn't until like the last day where he went so low, and I don't remember if it was nanoamps or picoamps, but we're talking like, 10 to the minus 9, 10 to the minus 12 magnitude in terms of current. And I thought that was fascinating because it just showed how minuscule that intensity of amperage was for communication in our body. And thus the resulting magnetic field generated from that current flow or, intensity and flux density of that would be really, really small. So at a high level, Becker he proved that biological semiconduction is real. And then he went on to also be a pioneer in the EMF space and testified, as part of this study for antenna construction design, that he was a part of a cohort in the Navy that kind of looked at a bunch of these studies, and then they hid that from the general public. And then he went against them and kind of tarnished his whole career in the public eye, which is a fascinating story, him and Andrew Marino. But yeah, whenever I talk about EMFs, a lot of people are fascinated. Like, why have we never heard of this? And you just point them back, hey, the 70s, this was a hot topic, electropollution. And this has just been swept under the rug for far too long. And I think because of that as well, a lot of the research that Becker was doing in terms of biological semiconduction, the funding just completely dried up after that. And he talked at length about the issues with centralized academia and funding sources for research. And yeah, that's kind of why it hasn't infiltrated the mainstream paradigm, because it's kind of a threat, or it's been seen as such, and that research just was not funded. But there was still plenty of research done and has been done even since the 90s that show detrimental health effects of non-native EMFs, and we can get into that later. But for me, Becker is a pioneer on those two aspects.
Yeah, and I believe he was an orthopedic surgeon, so he was actually a clinician. He was a clinician and a scientist who had obviously quite an insatiable curiosity and has done such pivotal and instrumental scientific work. The point about the dangers of EMF being kind of swept under the rug, I believe at the time the harms of non-native EMF in the context of the 1970s was a radar defense system, and
Mm-hmm.
the fact that it was inconvenient from a national security point of view to make it well known that this was having negative health effects. And if we fast forward all the way to today, the promotion or the rollout of high speed telecommunications networks is also has meaningful kind of health impacts. And again, maybe we'll talk about it a bit later. But the same resistance to that message getting out exists because whole economies are running on high speed information transfer, and you can see how it's quite inconvenient for it to be well known that that is harmful to human health. I want to make the point, go back to this idea of the body electric, and you painted this idea of the bone. So it's a critical structural component of our body, but it's also, as you mentioned, has these innate electrical um, properties. When I talked to Dr. Jack Cruz in my long series, he raised similar points to what you're talking about, and talked about proteins and various molecules in the body acting as semiconductors. So, what the point I want to make is that it's not only this electrical properties is not only happening at a macro level from a bone level, but it's also happening even further down on a mitochondrial level, and then even further down with compounds like melanin. So, what do you think, Tristan, in terms of this multi-level or multi-scalar appreciation of the electrical properties of the body?
Yeah, well, you pointed out exactly that, right? This isn't just happening in bone. This is happening everywhere. So melanin, hemoglobin, DHA, what we mentioned, water a little bit. Collagen is, comprised of a bunch of amino acids, right? And you can get into the aromatic amino acids as well, having that ring structure. And for me, I guess across the board is something that pretty much all these semiconductors can do is they absorb energy from light, and that is the energy that's needed to bridge the gap. So if you're not familiar with fundamentally what a semiconductor is, it's a material or molecule or what have you that has a band gap. But that band gap, so conductors like metals, they have no band gap, so electrons are able to freely move from the conduction valence band. Semiconductors have a band gap that is achievable through external excitation of or external energy to be able to transverse that gap. So, silicon is, I think, like 3 electron volts is what's used as a unit to measure that. And in the semiconductor industry, you see like 2, 3, 4, 5, 6 electron volts is common, but it could be even a little further than that. When you get to insulators, they have such a wide band gap that it's not feasible for an external energy to excite an electron to be able to bridge that gap. So the light component, I listed all these things, melanin, hemoglobin, DHA, water. Light is the driving force typically for what is the source of external energy to allow for that conduction to happen. But the parameters need to be very specific. And if you read about like DHA, for example, it's fascinating just how biology has figured this out on a fundamental level, and it's so precise, it's so accurate, that the conditions are just right. And the same thing with melanin. Although melanin can absorb the entire electromagnetic spectrum, it's dialed in to a very fine-tuned process. And that's because biology has evolved over millions of years to do this. So it's not by coincidence, it's not by mistake. And now, for the first time, we're really playing a giant science experiment when we're disrupting this process that's so highly fine-tuned with our modern lifestyles and modern external electromagnetic fields, which are light, non-visible light, fundamentally.
I had a recent podcast discussion where we talked about the demonization of sunlight, and I made the point that when you take an ancestral and an evolutionary lens, and you understand how deeply ingrained circadian rhythms are, and how the evolution of simple and complex life is yoked so closely to sunlight, it really makes a mockery of modern advice to avoid the sun. And I just was basically explaining and talking about things on a biochemical and a physiological level with regard to circadian rhythms, the biology of pro-pure melanocortin, and a range of other topics. But what you've just previewed, Tristan, is that there is a molecular level at which we're using light, and Dr. Jack Kruse is particularly famous for talking about the role of DHA and a range of aromatic amino acids that are able to capture light and then harness that light in a way that optimizes the biological function of the system. And it makes more sense when we understand the depth to which light is involved in human biology, when we can see that maybe it's not necessarily, I mean, the food system is a problem, and the fact that everyone's eating highly processed food is incredibly damaging. But taking this fundamental bioelectric light perspective, we can see how moving everyone indoors, insulating them from earthing and grounding, and then exposing them to Wi-Fi, 5G, and non-native EMF, how potentially momentous that is in terms of the changes that we've made societally that are affecting health.
Yeah, and to me, it's just a toxic threshold, really. And people always want to, everyone's writing their book on what they think is the most important thing or is causing chronic disease. But to me, it's disconnection across the board, right? I mean, like you said, it's this onslaught. We have, food that is highly processed, and then you could get into the quantum side of why that might be bad with deuterium and things like that. You have items like glyphosate, environmental toxins, plastics, PFAs, endocrine disruptors. You have non-native EMFs, and then you have this disconnection to the energy source. You have that disconnection to sun. You're always indoors, and instead being exposed to artificial light, which is disrupting so many biological functions and circadian rhythm. So to me, it's just that's what it is, and it's not just one thing. And you see these news headlines where it's like, oh, a perfectly healthy 30-year-old who got jabbed had a heart attack, and like, were they perfectly healthy? No, there's no way. Nobody is actually perfectly healthy. This is not even a real thing anymore, because it's impossible to mitigate and be completely absent of environmental exposures that are not biology is not designed to be around. And that's just the matter of fact. It's unfortunate, and that's why it's really important to educate on these topics. But it's important to not be, so fear mongering. It's important to understand that there are things that you can do. And like we talked about in the beginning, for me, it's the more connected I am to nature, the better I feel. And that's not a mistake. That's by design.
Yeah, it's a great opportunity to talk about grounding, because when I guess, laying the foundation of understanding that we're running a bioelectrical system, our mitochondria rely on the electron transport chain. I
Mm-hmm.
guess that and we evolved again. We evolved with in constant contact with the earth. Then grounding kind of makes sense, and it seems like it's been put in the woo woo basket. I mean, people like to think, oh, hang on, why would I ground? and and I mean, I'll get your perspective, Tristan, but I think that on a really basic level, it's like, well, okay, what were we doing for the duration of our evolution? Okay, we're in contact with either the ground, the trees, which are connected to the ground, or in natural bodies of water, and we evolved in the ocean, which was essentially completely bathed in free electrons in the form of essentially grounding. So talk to me about grounding and how you think about it.
Yeah, I mean, grounding to me is one of the easiest things to do to make you healthier, right? It's like you're saying, we're designed to just be connected 24/7, 365. Would have been ongoing for 99% of human existence, and now only because of insulated footwear and modern, I guess, furniture and things like that, and construction, we're not connected. And it's like a big deal if you're connected for an hour a day, or 2 hours. And yeah, fundamentally grounding. So the surface of the earth has this inherent a pool of free electrons, mostly coming from lightning strikes. So there's about like 6,000 lightning strikes a minute, or 44 a second, which, fascinatingly enough, I was kind of looking this back up again. Almost 80% of that is in the tropics, or between like 30 north and 30 south latitude. So I guess I'm not getting as much lightning strikes. So I wonder if the Earth is slightly less negatively charged up here at the surface at 45 north. But yeah, we're designed to absorb these free electrons, to be connected. How do we know that? Well, our hands and feet, they have more sweat gland density than any other area of our body. And why does that matter? Because moisture decreases skin resistance and increases conductivity. So an extremely dry hand could have 100 kilo ohms of resistance, and the higher that resistance is, the less conductive your skin is going to be. And you can look at the equation for conductivity, or look at Ohm's law: voltage equals current times resistance. And if your hands are sweaty or your feet are sweaty, it could be 100, or some people even say 1,000-fold less. So you have the ability to absorb 100x of the electrons that are available due to the negative surface charge, the very negative surface charge of the Earth. And that's key as well, because it's providing free and mobile electrons. And electrons that are free and mobile are the ultimate antioxidant. And I'm sure you've talked about this at some point at length on the podcast, but it's accessible to everybody, and it's the master antioxidant because it can get into any place needed in our biology. And what's often touted as the importance of supplemental or dietary antioxidants, but never discussed by those people who peddle that as a solution, is actually the issues that come along with a larger molecule serving as an antioxidant. And that's due to the inflammatory barricade, that's due to exclusion zone water being around the cell, that's really excluding anything that's larger than some of the size of these subatomic particles. So a free and mobile electron from grounding can easily get where it needs to go to combat reactive oxygen species, to keep the zeta potential high in our red blood cells, to build that negative charge on the exclusion zone up against that hydrophilic surface. So it's really, once you realize again how necessary it is to have sufficient electrical and negative charge, then you realize how important it is to have this stream of free and mobile electrons. And then what's really fascinating as well is the research that shows how grounding and earthing can regulate cortisol rhythms. And to me, that's under discussed because we don't even understand why that is. But again, if you're connected to the earth, you're connected, you're a part of it. As Richard Feynman would say, like the umbrella effect, you're connected to the earth. You are a part of that. So you're going to be in sync with your location on the earth. And that's probably why it regulates your circadian, your cortisol rhythms. It's great for jet lag. So it kind of has all these benefits, and it's completely free. And the research on it is, it's there, but it could be debatably said that it's not super strong. But you don't need to know, you don't need to have these fantastic research studies to know that grounding is one of the most effective ways to improve your health, and that we were designed to be connected to the earth.
Yeah, it's almost like a bit of a midwit test. If you think that you need a random, a bunch of literature, peer-reviewed literature to walk outside without your shoes on, then then maybe you don't pass the test. But the idea of grounding, I guess a question that I have, and especially from someone who's coming from a biochemistry-focused pathophysiological medical background, is okay, Tristan, that sounds great, but how does the electron get from the bottom of my foot and maybe in a sweat droplet all the way into my mitochondria of one of my neurons, in my parietal, or anywhere in my brain. Like, what is a process of actually incorporating that electron from the ground into my body, and in order to get to where it needs to go?
Yeah, that's a good question. And to be honest, I mean, I don't the exact mechanism. I don't know if there's any good research on this, but in general, electron flow, it happens at a very fast pace. And just like anything in the body, right? Like at a biochemical level, if something's in your blood, it's circulating throughout your entire body in a matter of seconds. So now you're on the subatomic particle level where things are traveling even faster. And again, that goes back to this whole communication matrix that's, to me, probably the most important aspect of our biology, and that's the water and collagen matrix, intracellular, interfacial matrix. And through that, water or electrons can actually semiconduct to get into cells. And because collagen is an n-type semiconductor, it's looking for that. But then again, like going back to the antioxidants, it blocks them from getting to, say, a cell or an injury site because they're too large, or they don't have that ability to transverse this, I guess, electrical blockade or inflammatory barricade that it has been dubbed. So yeah, I think it's an instantaneous, almost traversing of electrons throughout our biology. And it's really hard to think about this because you have to understand the amount of electrons that are flowing. Just a very even small amount of current is on the order of an insane magnitude. And it's fun to theorize that. But here's the real catch that I think people don't understand about electricity, is that electrons are not energy carriers. So when you have a battery and you're charging, or you're turning on a light bulb, people think that the energy to turn on that light bulb is being carried through the wires, right? If it wasn't for the wires, we wouldn't be able to turn anything on. And that's not true at all. The energy carrier is actually the electric field that's being generated from the source. And if you take the, cross product of the electric magnetic field and get that direction of energy flow, it's going to go towards the load. And that is because the wires are made of conductive materials. So the surface of those wires are then generating electric fields along the way, and that's the energy carrier of the electricity. That's how that power is being transmitted. So I'd imagine it's a similar thing in our biology as well. It's not the wires that are doing the work, it's the electric fields, it's the EMFs. And there's some cool videos you can watch on YouTube. But for me, this is kind of an eye-opening moment into, again, the importance of electromagnetic fields, and how people don't even really conceptually understand how electricity works. And that's something that's the most ubiquitous thing in our society today. And that's why if you go stand under a high voltage transmission line, you could light up a very dimly light up, a fluorescent light bulb. And yeah, it's fascinating. So kind of understanding the importance of EM fields in that regard, I would say, would play in a little bit to your question.
Yeah, and I think if anyone's interested in delving further into this, Carrie Bennett, who I've interviewed earlier in my podcast, she is an expert and she really explains the concept well. And she talks about fascial layers, ground substance, and this kind of electric superhighway that allows the transmission of this information and these electrons around the body. So you interviewed her recently. I enjoyed that episode on your podcast, Decentralized Radio. So we can include that in the show notes so people can find that information. The next question is how, or maybe you can tell us about the experiments that you've been doing with your body in terms of electricity and what you've been discovering.
Yeah, I mean, at a high level, well, first on, something that people always ask is, how should we ground, or is grounding, what are the best ways to ground? And I have like a good, better, best, I guess, response to that now. And this is still very highly debatable. And I talk to other electrical engineers about this constantly is, do the outlets, can I ground into an outlet, or is it okay if I just ground outside my house, grounding in cities? And this is some of the experiments I've been doing, some of the thought experiments, really. And for me, it's good, better, best to be, grounding to a properly grounded outlet is good. You might run the risk of, being exposed to some additional EMFs or quote unquote dirty electricity, which I don't even like that word, but grounding to a ground rod placed outside your house that's directly connected into the earth is probably better. But then again, you could argue that there could be some residual ground current or step potentials outside your house. So like, best is grounding in nature, like near nothing, or in the ocean, extremely conductive water, especially salt water. And yeah, that's what I would say is good, better, best for grounding. Grounding in cities probably not as good for many reasons, but I think you probably still get more benefits from it than harm for sure. And yeah, there's so many EMFs and cities that you probably need as much electron flow as you can get. And again, grounding, and what I've been doing in my experiments is showing that grounding basically completely mitigates the effect that electric fields, AC electric fields, have on your body. So when you're exposed to an electric field via capacitive coupling, a AC voltage is induced on the surface of your body. And this is completely unnatural. AC didn't exist until the inception of our power grid, thanks to Nikola Tesla. And it's something that we are not designed for. Nature, our bodies are designed and using DC voltage. So AC is oscillating at a specific frequency. Our power grid, whether you live in anywhere in the world, is either 50 or 60 hertz. And so that's 50, 60 cycles per second. That's the frequency. And what that's doing is also like flipping the incidence of the magnetic and electric field components at that frequency. And like I said, it's inducing this AC body voltage that we call it on the surface of our body. And this is one of the best ways to measure your electric field exposure. And what I've been doing in my experiments is kind of just measuring that. And I have just a multimeter here and a nice conductive surface so that I can easily measure the voltage. And yeah, you just set it to kind of AC voltage and touch it. And right now I'm at like 130 millivolts of induced body voltage. I don't know if you see that, but that's not bad. And what you want to aim for is as low as possible. But what I say is, 130 millivolts. What I've noticed is when you have a ton of appliances plugged in that are ungrounded, which are the most appliances like lamps, TVs. I mean, my podcast recorder device here is mixer is they're all two-prong plugs, right? Laptops, actually, if you have a MacBook, if you have an Apple product, iPhone charger, they're always two-prong. So if you don't have that ground, you are not mitigating the electric field whatsoever. So that electric field is then dispersing outwards 6 to 8 feet from the source. And that's then being induced on any conductive surfaces like your body. So you're being exposed to a way higher amount than really you need to. And what you can do to mitigate that is unplug any appliances that are two-prong plugs, not grounded, that you aren't using. So TV, if you're not using it, unplug it. Podcast mixer, if you're not using it, unplug it. Lamp, unplug it. You really don't need these things plugged in if you are not using them. Blender. I mean, it's really important for this distinction, because so many people just leave stuff plugged into the wall and they're like, oh, it's not turned on, it doesn't matter. That's completely untrue, because voltage is still live there. You're plugged in as a level of voltage, and whether it's 120 volts, 220, depending where you live, that's creating that electric field. It's only when you turn the device on that you're flowing current, and then from current you also get the magnetic field component, which has its other effects as well. But for me, the easiest way and what I've measured is unplug your appliances, and you can measure this via the body voltage via multimeter. Pretty easy to understand the effects and get it as low as possible, especially for your bedroom, because to me, the sleep sanctuary component of EMFs is huge. And this is where we're restoring, this is where we're repairing, this is where melatonin is released. We understand the significance of melatonin, autophagy, apoptosis, as a mitochondrial composer is, I mean, it might be the most important thing, right? And if you're just exposed to these non-native EMFs while you sleep, you're really going to be struggling. And studies have shown the disruption of sleep, both at a power frequency level of EMFs, so 50, 60 hertz, and at an RF level, so like your Wi-Fi, for example. That's not what I'm measuring. I'm just measuring the power frequency, electric field exposure. But what I've been experimenting with recently as well is completely turning the circuit breaker off to my bedroom. So if you have your bedroom on a completely separate circuit, turn it off. What are you doing in your bedroom? It should be one thing, sleep, and maybe one other thing, but you don't need power for that, really. If you need some light, you could bring in a candle, you could bring in something from another room. But the problem is, I don't recommend anybody doing that if they're going to flip their breaker on and off every day, because that's a safety hazard. So for me, I've been experimenting like flipping the breaker off for, a week at a time. And if I'm here for a prolonged period of time, just keep it off, because I don't need power in my bedroom. And I've noticed on my measurements of body voltage, that drops it significantly. And another thing I've noticed is metal bed frames. Again, what I say, conductive surfaces will be induced with a voltage. So if you have a metal bed frame, you're going to want to get rid of it or ground it. And also, an option is to just ground your body while you're sleeping. So if you ground your body while you're sleeping via the good, better, best method that I shared, then you don't have to worry as much about this. But that's kind of what I've been experimenting with. It's really cool to see this and see what really moves the needle. But I was just astounded at the impact just like a TV and a lamp could have on your induced body voltage.
Yeah, and most people are having their iPhone or their smartphone plugged in, charging next to their metal frame bed. That
So
that that
that's
that
terrible. And I would just say for that, if you're going to charge your phone, do it like via your laptop or do it with a 3-prong plug somehow. So I like to charge my phone like in my laptop, because then it's being charged from a DC source, not an AC source. And then my laptop's plugged in with a grounded 3-prong plug.
Yeah, I mean, it's fascinating and very quite technical from an electrical engineering point of view. From a high level, a kind of simplistic perspective that I like to take, it's simply a non-native form of electricity. That it's not the DC current that our body uses to communicate, which we spent the first part of the podcast talking about. It's a foreign electrical current, and we never were exposed to it ancestrally. So minimize it as much as possible. Again, it's like, where is the onus of proof here? And I feel like people especially with this modern, I guess, world where there's a almost deification of the science, and people won't even do anything. Some people won't even take a breath without checking to see if the science has endorsed that practice. But let's just keep it so simple, and let's just turn off all power, as Tristan said, turn off all power to your bedroom, make that a sanctuary. Don't charge your phone in there, um, and your sleep
But
quality
what's
will.
crazy, Max, is there actually is a lot of science, and you could pick out all these research studies, but for me, I always point everyone to kind of this one review, which is, or I guess one researcher is Dr. Henry Lay from University of Washington, and he basically looked at 2,500 studies from the 90s onwards. So it's not even including like stuff from the 70s and before then. And it shows like for radio frequency, 90% show significant health effects, and 96 of studies with the specific absorption rate SAR limit that's like a third of what the actual guidelines are. So it's way lower than the iPhone limits. 96% showing effect for for extremely low frequency, like the power frequencies we're talking about, like 90% of 300 plus studies published since 1990 showing significant biological effects. And then he got into some shit because he basically said that when industry funded studies, 70% of the time they showed no effect, and when they weren't, over 70% said they did. So that's what I like to share with everyone. Why, where's the research, blah, blah, blah. It exists. It's out there. It's been swept under the rug for decades. But if you look at a high level of a review from someone who's trustworthy like this, it's undebatable. And then you could get into the mechanisms of action, which is fascinating, but it doesn't really matter because it's going to show its face in many different areas, right? Mitochondrial dysfunction is the root cause or the root issue downstream, and then also disruption, I think, of the water matrix. But what does that turn into? For someone, it could be, reduced fertility. For someone, it could be, headaches or disruptive sleep, or long term, it could be heart disease, cancer. It just depends.
Yeah, and it's a great opportunity to talk about this concept of losing energy to the environment, and maybe obesity being a representation or manifestation of that. So, how do you think about this idea of energy loss at a biological level, reflecting something like metabolic disease? Because reversing metabolic disease is a particular interest of mine, particularly in my clinical practice.
Yeah, I think we just become such finely tuned creatures, like I said, that all of these processes, the mitochondria, the water protein matrix, like they're operating at a very finely tuned level. So then when we come in and disrupt that, whether it be with artificial light or non-native EMFs, or toxins like glyphosate replacing glycine in every third spot, then we are disrupting the efficiency of this process by causing these blockades, and thus the output is going to be lower. So, as an engineer, I like to just think of things as inputs, outputs, and if the output is being ruined, which is or lowered, which is the energy that we have. And I mean, you could debate what is energy, right? And what is the source of energy? Is it ATP? Is it melanin? Is it water, what have you? That's a fun discussion, but we know it's disrupted, right? We know it's lower. We know that there's issues, and fundamentally a lack of energy, a lack of cellular communication is leading to things like obesity, metabolic dysfunction. So the inputs are either being disrupted, or the system is being disrupted, and the inputs are not sufficient enough. So we're talking about electrons from grounding. There's not sufficient amount of electrons. Light is an input. There's not a sufficient amount of the right light. So when you look at all this, and then you add in the toxins and the disruptions, just circadian disruption across the board, you're going to get a system that's not very functional, that's not efficient. And it could have been 95% efficient before, and now in a modern world it's like 70. And over time you're just going to have lower and lower energy output. You're going to have higher heteroplasmy over time. You're going to have worse communication. So when you have worse communication in your cells, things aren't going to get executed properly. So you just cause this chaos, to me, like across the board, and eventually that's going to show its face in a tissue or a system, and then you're going to have that issue, that chronic health issue. And that's just a sign of things to come for me down the line if you don't do anything about it. And I think it's just a simple way to think about it, and you could align up all the inputs, align the output and the system what may disrupt it, and think about that, and that's how you fine tune a machine. And that's what I like to do as a thought experiment. And it seems like every day we're finding new information out about what could potentially improve or disrupt this very finely tuned system.
Yeah, it's a great transition to talking about the clinical aspects of this, which is the mitochondrial bioenergetic etiology of disease. And I feel like I keep coming back to this paper by Dr. Doug Wallace, who is a researcher in the Children's Hospital of Philadelphia, and he's been a decades of mitochondrial research. And what he's shown is that when you get failure of mitochondrial energy production, and there's a whole bunch of different ways that the mitochondria can basically break down, accumulation of mutations within mitochondrial DNA. And the way I think about it is the mitochondria, remember, is an ancestral bacterium, and inside it has hundreds or thousands of copies of a plasmid type DNA, which is like a circular ring of DNA, and maybe one of them is going to have a mutation in it, and maybe some of them more are going to have mutations in it, and those DNA encode for production of proteins on the electron transport chain. So it's like not a binary outcome, is it, Tristan? It's like the more mutations we accumulate, the reduced on a spectrum energy output that mitochondrion has. And then on a cellular level, because there's can be up to thousands of these mitochondria in each cell, then it's like a gradient where the cell then loses its output. It's unable to conduct its enzymatic capabilities as well. And then when that happens on a tissue level or in an organ, you get enough neurons failing or you get enough cardiomyocytes failing, then you get a disease-specific manifestation, whether that's heart failure, whether that's Alzheimer's disease, whether that's Parkinson's disease, or whether that's type 2 diabetes. And the industry that I work in has siloed the treatment of these diseases into organ-specific silos, but really we've got a common etiology, which is mitochondrial failure. And because of your your specific instance, then you've just manifested that problem in that organ. But it comes really down to the mitochondria, and the whole first part of this podcast is kind of talking about the background to how these mitochondria are functioning and dysfunctioning.
Yeah, you're completely right. And then that's why, again, like I said, the most mitochondrial rich organs and tissue areas of our body seem to be the most common for, I guess, issues with non-native EMFs and blue light and just chronic disease in general. And having that, mutation rate that's 10 to 20 times higher than the nuclear DNA, you can't get away with this stuff anymore. And it's sad. And it's funny when I see things like the blue zones, I see things like, oh, well, my grandpa was like 100 and he smoked and drank every day. You can't get away with that anymore. You just can't. They grew up, they were connected, they watched the sunrise. You didn't have to tell them to just go outside. They were probably working outside. They could have been raising their food, connected, leather shoes, and no artificial light. Maybe electricity got introduced when they were like 30 and 40 already. And that's where I have this big issue, right? Is the children. The children are set up for failure from the day they're born. And now we're giving kids iPads and iPhones at earlier and earlier ages, and they're even more susceptible. They're like, 2 to 10 to debatably even 50 times more susceptible to EMFs and just radiation across the board from technology because of their size, because of their water content is higher, because they have thinner skulls and developing brains. And that is just unacceptable for me. And that's why I think the education on these topics is so important. But going back to the mitochondria, it's really fascinating because you can pretty much outline, as an electrical engineer, you can pretty much redraw the entire inner mitochondrial membrane matrix as an electrical schematic, and especially the electron transport chain. And it's all fueled based on proton current. And you get this mitochondrial membrane potential that is, a voltage that drop across the membrane. And that's what's driving the, ATPase to produce ATP. And just electrical stimulation externally can affect this dramatically. And to me, it's just so fascinating to get into this and how these things are designed at a fundamental level. I mean, talk about the nanomotor, you talk about how there's actually like a stopgap in proton leakage current that's preventing the hyperpolarization of the membrane potential, basically from the whole mitochondria from exploding. And you can redraw that as a Zener diode electrically, which it's just so cool. But that's what it comes down to, right? Like it comes down to having the proper electrical characteristics in operation. And as you mentioned, once that heteroplasmy, once that mutations and the mutant DNA starts to increase, that all becomes dysfunctional. And then it's just a game of numbers after that point. How many mitochondria are going to be mutated, and then in what cells. And that's why, going back to sleep, if you don't have the proper sleep, you don't have the proper melatonin being produced to come and clean this up, apoptosis and autophagy in the mitochondria, then you're just going to be sliding off a cliff eventually, and it's going to manifest in whatever chronic disease that you think. And that's why all of this matters, from light to EMFs to diet, seasonality. Something I've been researching, which is really interesting, is just the reformation of the mitochondria based on input from diet. FADH2 to NADH ratio forming mitochondrial supercomplexes, and then you have people that are, talking about how you should measure your complex 2 activity. And if it's lower, you need to eat like more carbs or less fat. And it's like, no, it depends what season you're in and where you live, because that's circadian biology. That is the root of what is designed to do. And the adaptiveness of the mitochondria is incredible. And then it goes back to your haplotype as well. And Doug Wallace is the pioneer on that. And it's just, the rabbit hole is just keep opening up. But foundationally, the more connected you are to your environment, the more in line your mitochondrial function will be, I think.
Yeah, and look, I think about it this way: the mitochondrion, again, it was some form of ancient bacteria, non-sulfur forming bacteria, 2.4
Mm-hmm.
million years ago, when it got endosymbiosed. This process and complex life of which we are the end product, has been resulting from iterant improvement by Mother Nature in a highly selective do or die setting for this billion years. And Dr. Cruz particularly talks about this thermodynamic efficiency of the system. And if we tried to design a system like ourselves, it's nowhere near possible, because Mother Nature is always going to design the system in the most perfect way for the conditions which are evolved life on Earth. And when you disrespect those conditions that the system was engineered for, then disease is something that happens. So yeah, you're right. And look, I'm bringing it back to kind of lifestyle implementations and disease. I mean, one of my patients who has Parkinson's disease. Again, this is a disease of mitochondrial failure, and there's a Dr. Phillips in Australia is doing work on this, and he's focusing on mitochondrial healing protocols from like a dietary and fasting point of view. And sauna, sure, I agree that they're important, but sunlight and grounding, what we've talked about, Tristan, is so much a big part of this picture. And this patient particularly has noticed that his symptoms, and he has voice symptoms where his voice will become very, very faint as the day progresses. Those symptoms are rescued or improved when he's grounded in the morning sun. And
Mm-hmm.
we can make sense of that based on the context of this conversation, because he's optimizing that mitochondrial function in that morning. When he's grounded, he's getting free electrons from the earth. He's getting that infrared and red light that is maximizing his mitochondrial function. So it really ties everything together for me, as someone who's investigating and promoting preventative health as the root of what's going on. Because if we understand that everything from just general fatigue all the way to full-blown Parkinson's disease results from a spectrum of mitochondrial dysfunction, then putting people into that natural situation where their mitochondria are humming the best is this like blanket prescription in many ways.
Yeah, no, and it's funny because and what I tell clients and people that follow or follow me is, the blueprint's really the same. It's mitochondrial dysfunction, it's lack of connection to your environment, but the bioindividuality and the circadian context is real, right? Like you and I are in completely different latitudes, completely different environments, different seasons. So that's the context that matters. The blueprint, the issues are the same across the board, and it doesn't matter what health issue you have, probably. And that's the issue with our siloed, centralized healthcare system currently. So that's where some context is important, and that's why working with people can be really helpful. But it's pretty simple, right? And you didn't have to convince people 150 years ago to watch a sunrise. They just did that. That was when they got up. That was when they were out working. So they just did it. You didn't have to convince them that that was like an important thing for health. That was just their daily life.
Yeah, man, and look, I think we've really covered this topic well, and I want to get your thoughts on the food system and what you're doing with the bison. But before we do, what advice would you have for someone who's like, man, you've really scared me now, Tristan. I'm worried about my kids. How can we save the kids? How can we help ground them? My baby isn't big enough to walk on the ground yet. How can I ground my baby? How can I do all these things to kind of offset or mitigate the modern world? And we've talked a little bit about turning off the electronic devices in your bedroom, but talk to us a little bit about some practical steps.
Yeah, and at a high level, right? Like EMFs are harmful, and what you need to be cognizant of is distance, duration, and just intensity. I guess you could say, because distance is your best friend, right? Inverse square law: when you increase the distance by a factor of 2, for say, you're going to get the square reduction of that. So 4 in terms of reduction of the electromagnetic field. So distance is your friend. There's a huge difference between using your phone up against your skull and on speaker a foot away. That's a massive difference. That's why I'm not a fan of Bluetooth headphones as well, because your 2.4 gigahertz, there you go, selfie stick, or the tripod. But yeah, the 2.4 gigahertz Bluetooth, that's low power. Yes, I know it's low power. I worked in semiconductors. It's low energy, but the distance, the proximity, and then the duration. Yeah, if you're a finance bro, I swear these guys sleep with AirPods in. I don't know if it's just like a company policy or needed to make bad decisions on finance, but it's all the time, right? So the duration is really important, and there's some cool research studies out there that show, say there's like 100 papers in this study from subchronic exposure, like 2 to 48 hours, like 40, 50, maybe 60% of the papers show significant biological effects. Once you got to chronic exposure duration, like greater than 48 hours, it was like 97, 98%. So that's why I'm a big advocate of turning your Wi-Fi router off at night, turning your phone off at night, or in airplane mode, put it in the other room. You don't need to be accessible all the time at night. And that's why, I've been experimenting with flipping the breaker off to reduce the electric field that's running through my bedroom walls, as well as potentially the magnetic field component of that also. And we just know the impacts on sleep from both RF and from power frequencies. So reduce your exposure in that regard. Distance, duration, think about that. And if you have children, yeah, please be even more cognizant of that. Get them outside. Kids just want to be barefoot. If you just like let a kid go outside, they will lose their mind. They'll be the happiest person. My nephew is about to turn 2 years old next week, and he's outside just running around like literally all the time. Obviously, he eats like pretty decent food, but I think it's because of his connection to nature, being raised in like 10 acres in Wyoming. He's just outside all the time. He's in great health. He's speaking already. He's, growing fast. He's never really on technology ever. So don't use, as Jack would say, the technology babysitter is unacceptable. And just be very cognizant, because this is a developing child and brain. And once you expose them to this radiation like all the time, and the younger they are, the smaller they are, the worse it will be. And then you can get into specific nuances of your situation. I don't know where you live. I don't know what neighborhood you're in. There could be high voltage transmission lines. There could be cell towers, high EMF areas, schools, hospitals, airports, any power generation site, obviously substations and transmission lines. So the proximity you are there, you could get some decent magnetic field exposure from driving in your car if it's like a giant V6 or V8 or an electric vehicle. I'm running an experiment on that currently. So these are all things to think about, but don't be afraid because, again, we're all exposed to these things. It's really the duration, it's really the chronic exposure and intensity that you need to be worried about. So distance is your best friend, and just work to give yourself the opportunity to restore, recover at nighttime, and put emphasis on that sleep sanctuary. But if you don't know until you measure, so that's why I have, EMF meters, and this is a basic one you can buy, a tri-field. So it measures the magnetic field component, measures the electric field component, and then it has a specific setting for radio frequencies where it's taking the cross product of the magnetic and electric field as the power density reading. These things are like $150. Or you can book a consult with an EMF consultant, do it virtually, have that on my site, or in-person inspections, even better. And I know there's resources out there for that if you're really concerned. And it's something, to me, it's like it's worth investing in. And you can get, a multimeter and test your body voltage as well. It's not that challenging, and I'm going to put out more content around that. But you're investing in up front, and then you're kind of like mitigating your exposure for a very long period of time. So if you're buying a house, if you just moved into a house, these are things maybe you want to prioritize for you and your family, I would say, long term. But going back to all the other beneficial lifestyle habits to improve mitochondrial function will only help your resilience as well from being exposed to the EMFs.
Yeah, thanks for that. We'll definitely include all that information in the show notes. And I like that idea of measuring, because if you don't measure, you don't know. So maybe in the future we'll have everyone's going to have one of these EMF meters, and I mean, I can just think of the next hippie town is going to have no cellular towers whatsoever. Everything's going to have to be wired, and to reduce
Yeah, well,
this.
yeah, maybe DC power, everything's wired in. So again, you could go to the wired internet, get an Ethernet cable, that'd be good. But yeah, I want to educate more health practitioners on this. And actually, I'm building a course currently. It's almost done, so I'm going to offer that on my website probably in a month or two. And that'll be helpful if you're a practitioner learning, because then you can educate your clients on what matters. And it's, again, it's complex, but it's really not that hard to learn how to measure things. And actually, most of the EMF consultants out there aren't electrical engineers either. So it's daunting, but it's very doable for anyone who has the willingness to learn, I would say.
Amazing, epic, mate.
Kate. And yeah, we're doing a lot of great stuff here. So if you're listening to this podcast, you're on the right train. Continue to investigate these topics. Yeah, I'm at Decentralized Radio. Ryan and I do a podcast. We've had Max on. We've had a bunch of Bitcoiners on. We've had quantum circadian focused podcasts. And we're going to keep churning out education as well. Personally, like I mentioned, I'm going to be launching an EMF course. So if you want to learn more about that, check out my website, subscribe to my newsletter. I do have EMF consultations that I do virtually. And then, yeah, I'm most active on Twitter/X, which is at Bitcoin and _ beef. If you want to reach out, ask me any questions. I'm also on Instagram at Tristan _health. And yeah, I think that's pretty much everything. Well, I appreciate you, Max, for this fantastic conversation. Yeah, we covered a lot. It's cool to talk with people that are well-rounded, that are all-encompassing in terms of decentralization, because it just, they get it. You look through this lens once and you apply it to all aspects of your life. And there's a lot of great folks out there educating on Bitcoin, educating on regenerative ag, educating on circadian health and quantum health, but it's all the same principles. So let's keep aligning that. And yeah, thanks so much for having me on, Max.
Yeah, you're welcome. I really, really enjoyed this one, and I can't wait to share your message with the audience. So we'll stay in touch and have a great day. We'll talk soon.
Cheers.